Hello everyone, welcome back to my YouTube channel Physics Unification. This is the part 2 of the chapter Current Electricity. In this video, we are going to study some important 3 marks and 5 marks derivation from the same chapter. First of all, what we have to know about resistors. Resistors. Resistor is a circuit element which offers opposition to the flow of charges through it. There are two major types are there. First one, wire-wound resistor. Second one, carbon resistors. Wire-wound resistors are made by winding the wires of an alloy manganese constant nichrome. Carbon resistors are compact, inexpensive, and hence which is used in electronic circuits. Carbon resistors are small in size, hence their values are given using a color code. Color code for resistors. The set of coaxial colored rings found on the body of the resistor. The resistance of the resistor and its percentage accuracy is determined using the significance of colored rings following a code called the color code. The color coding can be remembered by the following way. B.B. Roy of Great Britain has very good wife wearing gold silver necklace. In another way, B.B. Roy goes to Bombay via Gateway of India. Color of the first ring on the extreme left gives the first digit, color of the second ring gives the second digit, third ring gives the multiplier, which the first two digits can be multiplied. The fourth ring determines the tolerance of the resistor. Gold indicates the plus or minus 5% tolerance, silver indicates plus or minus 10% tolerance, and if no band is there, which indicates plus or minus 20% tolerance. Combination of resistors. First of all, what we have to know about equivalent resistance. Here, equivalent resistance which produces the resistance of the single resistor, means which produces the same effect as that of the combination. First of all, series combination. If two resistors are said to be in series, if only one of their endpoints is joined. Here, R1 and R2 are the two resistors which are connected in series combination. This means that here what happens, same current I flows through the resistors R1 and R2. By Ohm's law, potential difference across R1 can be written it as V1 equal to I into R1, and potential difference across R2 is V2 equal to I into R2. Therefore, the potential difference V across the combination becomes V is equals to sum of the individual potentials V1 plus V2. Here V is equals to value of V1 is I into R1 plus value of V2 equal to I into R2. Here I is common in both the V1 and V2. So just take outside, then it becomes I into R1 plus R2. If the combination had an equivalent resistance Rs, then from Ohm's law, Rs can be written as Rs is equals to V divided by I. Then value of Rs equals to value of V becomes I into R1 plus R2. I into R1 plus R2 all divided by I. Here I gets cancel each other, and which gives value of Rs is equals to R1 plus R2. That is, in series combination, equivalent resistance is equals to the sum of individual resistance R1 plus R2. For n resistors, equivalent resistance Rs becomes R1 plus R2, so on up to Rn. In series combination, what we can conclude? Here in series combination, current is same and which is equal to the main current. The potential difference across the combination is the sum of individual potentials across the resistors R1 and R2, and the Same potential difference across any resistors is directly proportional to the resistance of that resistor. That is, V1 is directly proportional to the value of R1 and V2 is directly proportional to the value of R2. The effective resistance is always greater than the highest resistance of the combination. Here, this series combination of resistors is very important for 3 marks derivation. Next derivation is parallel combination of resistors. Two or more resistors are said to be in parallel if one end of all the resistors is joined together and other end of all resistors are joined together. Consider two resistors R1 and R2 which are connected in parallel with the common potential difference V, and I is the current which is flowing through the resistors R1 as I1, R2 as I2. In parallel combination of resistors, potential difference across the resistors, both the resistors are same, and I1, I2 with the currents through the resistors R1 and R2. Then I be the main current through the combination. Then main current can be written it as I is equals to sum of individual currents I1 plus I2. Equation 1. Then potential difference across R1 according to the Ohm's law can be written it as V is equals to I1 into R1, which implies I1 is equals to V divided by R1. And for R2 resistor gives V is equals to I2 into R2 implies I2 is equals to V divided by R2. Now equation 1, I is equals to I1 plus I2 can be written as I is equals to I1 becomes V divided by R1 plus I2 becomes V divided by R2. Here V is common in both the values. Just take outside, then what we will get 1 by R1 plus 1 divided by R2. If the combination is replaced by the equivalent resistance Rp, then by Ohm's law, I can be written as V divided by Rp. Equation 3. Now by equation 2 and 3, what we can write? V divided by Rp is equals to V into 1 divided by R1 plus 1 divided by R2. Here V gets cancel each other, and what we will get it finally 1 by Rp is equals to 1 divided by R1 plus 1 divided by R2, or Rp is equals to R1 R2 divided by R1 plus R2. 1 by Rp is equals to 1 by R1 plus 1 divided by R2 for n number of resistors. 1 divided by Rp is equals to 1 by R1 plus 1 divided by R2 plus 1 divided by R3, so on up to 1 divided by Rn. In parallel combination of resistors, potential difference, that is V, across each resistors is same, and which is equals to the potential difference across the combination. The main current is equal to the sum of the individual currents through the individual resistors. The current through any resistor is inversely proportional to the resistance of the resistor. See here, I1 is inversely proportional to the value of R1 and I2 is inversely proportional to the value of R2. Here effective resistance Rp is always less than the least resistance in the combination. So this derivation which carries for 5 marks for the examination. Let us see the problematic part. 3 resistors 2 ohm, 3 ohm and 6 ohm are combined in parallel. What is the total resistance of the combination? If this combination is connected to a battery of EMF 3 volt and internal resistance 0.5 ohm, determine the current through the 2 ohm resistor. Here given quantity R1 equal to 2 ohm, R2 equal to 3 ohm, R3 equal to 6 ohm, E equal to 3 volt and R equal to 0.5 ohm. Here what we have to find out? Total resistance of the combination Rp and the current through the resistor 2 ohm, that is I1. To find out the current through the resistor 2 ohm, what we need? V divided by R. V means the potential difference. How we have to find out the potential difference value? By knowing the value of E minus I into R. Before finding out the value of terminal potential difference, first of all, what we have to find out? Value of I, that is main current. How we have to find out the main current value? I equal to E divided by capital R plus small r. First of all, we have to find out the value of total resistance of the combination. It is 1 by Rp is equals to 1 divided by R1 plus 1 divided by R2 plus 1 divided by R3. 1 divided by Rp is equals to 1 by 2 plus 1 by 3 plus 1 divided by 6. Here it becomes, just take the LCM of 2, 3, 6 which gives the value of 6. Then 2, how many is a 6? 2, 3 is a 6. So 1 into 3 which gives the value of 3. Plus 3, 2 is a 6. So 1 into 2 is value of 2. Plus 1 which is equals to 3 plus 2 plus 1 is 6 divided by 6. 1. Therefore value of Rp is equals to 1 ohm. Now we have to find out the value of current. Main current I expression becomes E divided by Rp, means equivalent resistance Rp plus internal resistance R, which is equals to 3 divided by 1 plus 0.5, which is equals to 3 divided by 1.5 or 30 divided by 15. 15 ones are 15 twos are, which gives the value of I equal to 2 amps. Now we have to find out the value of terminal potential difference. V equal to E minus I into R. V equal to capital E value is 3 volt minus I value is 2 into R value is 0.5. Therefore, which is equals to 3 minus 2 into 0.5 value is 1. Then value of V equal to 2 volt. Now at the finally, what we have to find out? Current through 2 ohm resistor, that is I1 equal to V by R1. Value of V equal to 2 divided by R1 value equal to 2. Therefore value of I1 is equals to 1 amps. That means the current flowing through the resistor 2 ohm. Which completes the second part of this chapter, current electricity. If you have any doubts regarding these concepts, please drop a comment in a comment box. Stay tuned, like, share and subscribe my YouTube channel Physics Unification. Thank you.